to find the axial forces. Okay, so let me get the image again. Okay, the image is here. Right. Okay, so this is weird. It should not be doing this. Undo. My bad. Undo. I will come here. I'll paste. Okay, better now. Okay, so I'll string it down. So if you look at point C, we're going to apply method of joints. Okay, so this is our point C. So our point C has a vertical load coming down, and this vertical load coming down is 250 times 10 to the power 3 Newton. Okay, I'm going to draw the centroid for BC and AC. Okay, so I'm going to sketch the centroid for BC. Okay, so this is our centroid for BC. And then I'm just going to sketch our centroid for AC. Okay, so that is our centroid for AC. So if this is our point C, not if, when this is our point C, and currently we have 250 kilonewtons pushing it down. Okay, the only structure that can take a vertical load, let me call the transformation. Okay, this is X and this is Y. Okay, the only member that could carry the vertical load 200 times 10 to the power 3 Newton is member AC. Okay, because member BC is horizontal, it cannot take any vertical load. Okay, so we will have over here, this is our ACY. And ACY, okay, if that's your ACY, this direction will be your ACX. And then this direction over here will be your FAC. Okay. So when this is the case, if we have a member over here, and it's a fact that we have a member AC over here, okay, so this is our member AC, right? And we apply Newton's third law, action equal to reaction, same in magnitude, different in direction, right? So this is also your FAC. So that's why FAC over here, this is under what? Tensile. Okay, this is just using pure physics. Okay, I did not use experience at all. I just used Newton's third law. Then let's look at BC now. Okay, now by looking at BC, we know that ACX is going towards the left. So BCX must go towards the right, right? Because if ACX is going to the left, if we don't resist it, it will keep on going to the left. So BCX must go towards the right. Okay, so now if we were to draw a member over here, right? Action equal to reaction, same in magnitude, different in direction. So this is your BCX, which is also equal to your FBC. And then this will come in. This is also your FBC. So FBC is under what? Compression. Again, this is just using pure physics. Nothing to do based on experience. Okay. So this is what we call method of joints. Okay. So from here, we can determine what is our FAC and our FBC. Okay. So from here, we know that ACY. So we do summation about forces in the x direction is equal to 0. Oh, sorry, I'm going to do the y, sorry. So up is positive. The magnitude of forces in the y direction is equal to 0. So you have ACY minus by 250 times 10 to the power 3 is equal to 0. ACY is equal to 250 times 10 to the power 3 Newton. Okay, and we know we are going to find FAC. Okay, so I'm going to use similar triangles. Okay, so 250 times 10 to the power 3 divide by 3 will be equal to FAC over 5. Okay, so therefore FAC will be equal to 5 over 3 divide 5 over 3 times by 250 power 3 is equal to 416. Is equal to 416.667. You can use the angle. The answer will be the same. We know this angle is equal to what? Tangent of 3 over 4. And this is equal tangent, or sorry, 3 inverse tangent of 3 over 4. And the angle is equal to 36.86. Okay. So if you want to use angles, or you can use you can find out that your FAC is equal to 250 times 10 to the power 3 divided by tangent 36.86. Okay, so tangent 36.86, 250 power 3 divided by is equal to 250 power 3 divided by tangent 36.86. Hold on, I might AC FAC. I might be doing no, it's not tangent. What am I doing, Eugene? Come on. Seriously, that's your ACX, sorry. So this will be equal to sine, sorry. 36.86. I do apologize, okay. So 250 power 3 divided by sine 36.86 is equal to 416.762. It's about the same, times 10 power 3 Newton. Okay, so both ways is fine. Okay. So from here, we know what is our FAC already. Okay. So what I'm going to do, I think is also I'm going to find FBC also. Okay. So we can find what is our ACX. Okay. So to determine our ACX, we know what is our ACY. Okay. So I'm going to use like similar triangles again. So 250 times 10 to the power 3 over 3 is equal to ACX divided by 4. Okay, so therefore ACX is equal to 4 over 3 times by 250 power 3. Okay, which is equal to 3333.333 times 10 to the power 3 Newton. Okay, or again you can find ACX is equal to so tangent, so it's equal to 250 times 10 to the power 3 divided by tangent 36.86. Okay, so 250 power 3 divided by 36.86, or 250 power 3 divided by tangent 36.86 is equal to 333.453 times 10 to the power 3 Newton. Okay, either way is fine. Okay, use either way is fine. So from here, we can do summation about forces in the x direction is equal to 0. So we have ACX, which is going towards the left, minus 333.333 times 10 to the power 3 plus plus by BCX is equal to 0. So we know that BCX is equal to 3333.333 times 10 to the power 3 Newton. And we also know that FBC, this is also equal to FBC. But we know that FBC is under what? Compression. Okay. Right. So now we have everything already. Okay. So let me copy this image. Right. So we have everything already. So we are going to look at failure mode number 1. Okay. Failure mode number 1 for cable AC. Okay. So for cable AC, what we are given that the yield strength, let me get the question over also. Okay, let me get the question over. Or just look at this. We know that the stress yield, right, is equal to 1800 times 10 to the power 6. Okay, so stress yield is equal to 1 times 10 to the power 6 Pascal. And we know that the factor of safety is equal to 1.5. Is it 1.5? Yep, 1.5. It's 1.5. So the maximum or the allowable is equal to stress yield divided by the factor of safety. Okay, factor of safety. So this is equal to 1800 times 10 to the power 6 divided by 1.5. Okay, so 1800 power 6 divided by 1.5 is equal to 121200 times 10 to the power 6 Pascal. Right. So the maximum stress on AC is equal to FAC divided by area. So FAC, we know what it is. We did the method of joints. FAC is equal to 416.667. Okay, 416. And then the area is pi. The radius, I can't remember now. The radius is what? The diameter is 25, radius is 12.5. Okay, so 12.5 times 10 to the power minus 3 squared. Okay, so 416.667 divided by 12.5 power minus 3 divided by 12.5 power minus 3 squared times by shift pi. 416.667 divide by our area. So it's 848.827. Okay. Go on. Is it kilonewton? Yeah, all these are in kilonewton. I do apologize. So I need to times 10 to the power 3. Okay. So this is times 10 to the power 6 Pascal. Okay. So 416.67 power 3 divided by 12.5 power minus 3 squared. Okay. 84.827 times 10 to 1. So therefore,